Okie dokie, today we are doing equal, not equal, and we are continuing to discuss fractions and decimals, so let's have a look. I think these first few, you should be able to get most of these on your own by now, but let's just talk about a couple of them. First of all, just read the directions carefully. Which equation is correct? And the second one, the equation that is not correct. So it says equation singular, you're looking for one of them that is not correct. And I think, again, you can do these on your own. So just have a look. And number 2, let's see. Yeah, I mean, just be careful about a couple of things we've already learned. So 6/10, just remember that's also going to be 60 hundredths. So if you do that, you're going to know, okay, that one is okay. You may be curious about this one here because you have a half in the denominator of the answer in 12ths. But think about it. If you do 10 12ths minus 4 12ths, that's going to give you 6 12ths, which is also equal to 1/2. So that one's actually okay too. So you're going to need to look at the other two and figure out which one doesn't work. Okay, and then again, I think those you can do on your own. But again, part of this is just following the directions correctly. Here, which statements, which means there could be more than one, possibly, or no, there is more than one, are correct. And down here, again, statements, so there is more than one, are not correct. So just be sure you're reading the directions correctly for these. I think they're a little bit tricky with the directions. The one new thing here is some of these you're comparing decimals to fractions. Decimals to decimals and fractions to fractions should be okay. Decimals to fractions, we need to think a little bit more carefully about those. So let's have a look at those quickly. So the first one says 5 hundredths is equal to 1/2. So just be aware, 5 hundredths is only going to be 5 little boxes out of 100, and half, okay, so that is not correct. So that would be filled in. How about this one? 4/10 would be 4/10 versus 60 hundredths. So again, if you look at these, that's going to be equal to 6/10. So yeah, I think that one's also not correct. And then have a look at the other ones and see what you think there. Then we have a number line, which we've worked on in class as well. So I would start here with which one of these do you know the most? Okay, I know this spot right here between 1 and 2 is exactly 1/2, but I don't have 1/2 here, but I do have the decimal version of 1/2, so I know that one goes there. Okay, and then that should help you put in the other ones that are mixed numbers here, 1 1/4 and 1 3/4. Well, where would they go compared to 1/2? Which one would go where? I think you can figure that one out on your own. Then remember, if I was going to do 1/4, it's going to be half of a half. So here's half. Half of a half is going to be about there. That's probably going to be my 1/4. And what you need to remember here, this is probably going to be 3/4, but we don't have 3/4. But which one is 3/4? Well, if you have a decimal grid, 3/4 would be 25, 50, 75 hundredths. So 3/4 is going to be right there, or as is written, this one here. And then the rest of them you should be able to figure out on your own. There's only one more we haven't discussed. So next up, it's kind of the same thing we did here. Look, this is very connected to this up here. I actually think you can probably do this on your own, but for 0.75, you're going to fill in basically 75, so there's 50, 25, 50, there's another 25, that is 75. So as a fraction, you could do that out of 100, or if you cut it into that number of parts, you would have fourths. And how many of the fourths are filled in for that? And then up here, we're looking just at tenths, right? So you have 1, 2, 3, 4 tenths. So you can write 4 tenths as a decimal, and as a fraction, you can put it in tenths forms and in hundredths form. And then down here, we have a very similar fraction to draw and put into a decimal. And now let's get into this part that is the stories. So Daniel's collecting baseball cards, and he's putting them to a binder, and each page holds 9 cards in a 3x3 array. And you probably do not collect baseball cards. I did when I was a kid. You might be more familiar with something like Pokemon cards. So I grabbed a couple images just so you can see what we're talking about here. He's putting them into these pages where it's 3x3 array. So 3x3, 3x3, you can fit 9 cards into the array. So that's what we're working with when we're talking about this. So you'll probably want to draw some of these 3x3 arrays for the baseball cards. And the first page is 4/9 full. Okay, so 4/9, so you can go ahead and figure out what the first page looked like. And then the second page is 1/3 full. So this page is 1/3. So can you do thirds and fill in 1/3? And then what if he moves that 1/3 into there? What fraction would he have if he moved 1/3 into the other page? So you could do it and move those over, and what fraction of the page would be full? Okay, but then we have Sienna, and she also has baseball cards, just like Daniel's, and her last page was 6/9 full, and this is where it gets a little bit of a challenge. Okay, of the 6/9, she gave 1/3 of those cards to Daniel. So now we're not talking about 1/3 of the page, of the full page. We're talking about 1/3 of this 6 remaining cards. So what would 1/3 of these cards be like? This is what she gave to Daniel. Now the question is, okay, well, first A, what does Sienna have left? And then B, can Daniel fit all of the cards on his first page if he puts this 4/9 and this 1/3 and what Sienna gave him? Will that all fit together into Daniel's cards? You may want to use colors here to do this. So we know Daniel had this much to start, and then he moved in 1/3 of a page, and then he moved in part of Sienna's cards. So can he fit it all? And that is that. So thank you for watching, and goodbye.